Hello students, today we are going to take up the topic of P block elements group 15. Under that we will be discussing hydrides of group 15, elements, halides, oxides. So let us start with a very good thought. Dreams and dedication are a powerful combination. So when you dream of something, if you follow it with dedication, you will achieve the synergesis. Synergesis means combining two forces and resultant outcome will be success. So learning outcomes from this session is you would be able to explain about the hydrides, about the halides, about the oxides of group 15 elements. For example, hydrides ammonia phosphine, halides PCl3, PCl5, NCl3, oxides NO, NO2, N2O5 and others. Along with that, we will be discussing about anomalous behavior of nitrogen. So let us start group 15 elements. As you know, you should be able to tell the names of group 15 elements: nitrogen, phosphorus, arsenic, antimony, bismuth. Similarly, atomic numbers also you should be aware of how to remember. Earlier also I told you the nitrogen and phosphorus you will be knowing. So after phosphorus 15 is there, you add 18 and then again 18, then 32, then you will get the atomic numbers. Electronic configuration and all that we have discussed already, and you should be aware of that in this group 50 elements, two elements are metalloids like arsenic and antimony, and bismuth is metallic, and down the group metallic character increases, electronegatividity decreases, electropositive character increases, atomic size increases down the group. These basic things you should remember whenever you are starting any topic, any video. So always follow the basic principles, basic inorganic principles you should remember. Okay, next, under that we are going to discuss about the hydrides. Hydride means hydrogen compounds with group 15 elements. Let us say nitrogen's valence is 3, hydrogen is 1, cross multiply NH3. Similarly, phosphorus 3, H1, cross multiply PH3, arsine, stibine, bismuthine. So now the point is, what about the size? Size, you know, size of nitrogen, phosphorus down the group atomic size increases. It means the bond length of nitrogen hydrogen bond will be less as compared to bismuth hydrogen bond. If bond length is large, it will easy to break. So therefore bond dissociation energy down the group will decrease. Therefore it is not stable. Which is not stable? Bismuthine and ammonia will be more stable. So it means that stability we are not telling as thermal stability. Thermal stability decreases down the group. Okay, and that we say the bond dissociation energy also decreases. The bond dissociation energy also known as enthalpy. Enthalpy units are kilojoule per mole or joule per mole. Okay, so now let us discuss about the boiling points. So if you see the group 15 elements only, this is a comparison is given for between 14, 15, 16 and 17. So let us see here ammonia, phosphine, and then this arsine and stibine, and these are given. So now as you see that phosphine onwards the trend is in upward direction, means as the atomic size increases, the boiling point increases. But what about ammonia? What happens? Why it is abnormally showing? Abnormally showing why? Because ammonia can undergo intermolecular hydrogen bonding, which leads to association. Association means boiling point will increase. But in case of phosphine, because phosphine is a gas and all the other hydrides are also gas, there will be molecular interactions, not hydrogen bonding. There will be van der Waals forces, and you know that van der Waals forces is directly proportional to size or molecular weight. More the molecular weight, more the atomic size, more the surface area, the boiling point will be more. So down the group boiling point is increasing from phosphine to further arsine and stibine. Okay, but ammonia is showing abnormal trend. Why? Because ammonia undergo intermolecular hydrogen bonding. Why not phosphine? Phosphine is having large atomic size. So this is the condition for hydrogen bond. The size of the central atom, nitrogen, it should be small. Yes, of course, nitrogen is small. And electron should be more. Of course, that is also right. The nitrogen electron activity is more. So, condition of hydrogen bonding, you should remember the size of central atom should be small and the electron activity should be high. Now, let us discuss about the bond angles. So, bond angle when we discuss about ammonia. So, before that, we should be aware of the hybridization. Ammonia hybridization, nitrogen having 5 valence electron, 5 plus 3 A divided by 2, 4 means sp3 hybridization. Similarly, phosphine and arsine also having sp3 hybridization. More you want to know about the hybridization, you should follow the basic principles of inorganic chemistry videos. We have made 4 videos. Out of that, 4th video is regarding to hybridization. Please do check that. Very important video that is. So now we are going to talk about the bond angle is decreasing. Why? So previously I would like to tell you that if ammonia is having sp3 hybridization, the angle should be 109.5. But the angle is changed from 109.5 to 107.8. Why? Because of one lone pair. This is not a regular shape structure, regular geometry of tetrahedral. No, this is a pyramidal shape. Why? Because of presence of one lone pair. Okay, so due to lone pair, the Vasper theory, the tetrahedral shape changes to pyramidal due to presence of one lone pair. Now the next question regard to that is why the angle of ammonia is large as compared to phosphine. As reason is explained here, central atom, the size down the group it is increasing. Yes, of course, nitrogen, phosphorus, arsenic is increasing atomic size. Electronegativity is decreasing. What is the meaning of electronegativity? Electronegativity is the tendency to track the shared pair of electron. It means the bond between nitrogen and hydrogen in the both two bonds which they are very close. So if the bond pair is very close, what will happen? Repulsion will be more. So more is the repulsions between the bond pair and bond pair, there the angle will be more. So that is right. 107.8 is more than 93.6 because phosphorus size is large and is away from the central atom. The bond pair is away from the central atom and the distance between the pH bond is more. Thereby the repulsions are less and the bond angle is also less. So this is the point. So we should draw the structures, then you will understand more. Already in the book you will find the structures of pyramid structure ammonia, phosphine. When you draw, you will come to know that why the size is the small length is the bond angle is decreasing down the group. Similarly, basic strength of MX3. M means any nitrogen, phosphorus, arsenic. It's not M is not a metal. M is just a central atom. Central atom. Okay. So now here ammonia, they are telling that ammonia is the most basic. So you know that down the group atomic size is increasing. Nitrogen down the group atomic size increase and nitrogen having the smallest atomic size and it is having one lone pair of electron. Nitrogen is having one lone pair, 3 bond pair in case of ammonia. So now in the case because of lone pair donor tendency it is acting as a base as per Lewis acid base theory. Now the size of nitrogen is small, so area will be small and volume will be less. So we can say that electron density on nitrogen is more because what is density? Density is mass per unit volume. Mass means charge here. Charge density we are talking of, not the mass simple density. Charge density. Charge divided by volume. Volume is small, charge is same. So density would be, electron density would be more in case of ammonia. Therefore, the basic strength would be more and therefore a proton accepting tendency will be more. So fine. So next is thermal stability. We have already discussed reducing character. Reducing character means it is hydrogen provider. Hydrogen provided is only possible when nitrogen-hydrogen bond is what? Nitrogen-hydrogen bond is weak. So where it is weak? Where thermal stability is minimum. Where thermal stability is minimum? Bismuth and hydrogen thermal stability is minimum. So it means it will be available easily for the donation. So reducing character increases down the group as thermal stability opposite is reducing character. More is the thermal stability and more is the reducing character. Okay. So more is the thermal stability, lesser will be the reducing character. Okay. So this way thermal stability means it can break easily. Break easily is bismuth. So bismuth means reducing agent will be maximum for bismuthine. Melting point, boiling point we have discussed already. Only there is abnormal trend for ammonia because of intermolecular hydrogen bonding. Otherwise down the group the boiling point is increasing. Next is we are talking of halogens. Combination means the bond formed between the group 15 element and halogens. So you know that phosphorus can have the valency of 3 or 5. If 3 or 5 is there, so we can have PCl3, PCl5 or PF3, PF3 and PF5 or NCl3, NCl5. So nitrogen does not show pentahalides, NCl5 does not exist. Why? Because of the absence of d orbital. Nitrogen, you know the atomic number 1s2, 2s2, 2p3, n is equal to 2. L can be 0 or 1, S or P. So only 2S and 2P are possible. 2D is not possible in case of nitrogen. That's why we are saying it is not having empty d orbitals. That's what we are talking of. But in case of phosphorus, it is having. Let us see how. 1s2, 2s2, 2p6, 3s2, 3p3. N is equal to 3. L is equal to 0, 1, 2. And SPD. It means 3S is also possible, 3P is also possible, 3D is also possible. That's the reason that phosphorus can extend its covalency to 5, but nitrogen cannot. Okay, next is all the trihalides of these elements except those of nitrogen are stable. Like other halides are stable, but nitrogen is only very small. Where size of the fluorine is small, size of the halogen is small, that is only stable, because the more is the variation in the atomic size, the poor would be the overlapping. Overlapping of what? Overlapping of atomic orbitals. And you know that overlapping of atomic orbital will be less, so it means stability will be less. So why? Sigma bond is there. So you remember in plus one that overlapping the sigma bond and pi bond. Okay, so here all the sigma bonds are there, no double bond required. Okay, so now next is bismuth. Bismuth is metallic. So if you are talking of these are covalent halides, let us say NCl3, PCl3, PCl5 and BiF3, that would be what? It would be ionic nature or least covalent nature. Okay, fine. So why? Because you know that because metal halides are ionic in nature. Fine. Next is group 15 elements. Examples we have discussed already: PF5, PCl5 and similarly PF6 positive and PCl6 negative, because phosphorus can exist in this form like PCl5 plus and PCl6 negative. Like this also interchange of chlorine is possible or halogen is possible. So these are the oxides and halides. We are going to discuss more about the oxide in the next slides. So see here, these are very important questions and reason based questions can be asked. Stability of trihalides. NF3 is more stable than NCl3. Why? Because overlapping. If difference in the size is more, like nitrogen fluorine, nitrogen bromine, the size difference is more in case of NBr. So NBr3 will be the least stable. Okay. Similarly, Lewis base character also. Now here, what is the basic thing is fluorine, chlorine, bromine, iodine is different. Nitrogen is same. So you know that fluorine is most electronegatives. So if fluorine is more electronegatives, if it is combined with nitrogen, the fluorine will try to extract let us say to attract the bond pair of electron towards itself. So nitrogen will be having small positive delta charge. If small positive delta charge is coming on nitrogen in case of NF3, what will happen? It will not be able to donate electrons, the lone pair. So therefore the Lewis base strength is decreasing. It means the electronegativity is more of the combining halogen. There the tendency to donate lone pair will be least. And iodine, you know that it is the least electronegativity. The tendency to donate electron will be more in case of nitrogen in Ni3. Therefore the basic strength will be maximum in case of Ni3 and least in case of NF3. Okay. So now bond angles are also the same thing. So now you see Pi size is bond, the bond length will be large, and because bond pair portions decrease, therefore the bond angle is increased as you go down the group. Okay, so now I would like to ask one question from you is, let us say, tell me the hybridization of PCl3. PCl3 hybridization, phosphorus is 5, chlorine is 3, 8 by 2, 4, sp3. sp3 tetrahedral, but actually there will not be tetrahedral. It is not triangular planar, it is not tetrahedral, it is distorted tetrahedral, means it would be pyramidal. Fine. So one lone pair is there. Now these are oxides. Oxides of group 15 element like nitrous oxide N2O, nitric oxide NO, dinitrogen trioxide N2O3 and dinitrogen tetraoxide N2O4, N2O5. So now what you can observe, if you go down from nitrous oxide to dinitrogen pentoxide, what you are feeling, what you are finding? The oxidation state is changing. Oxidation state, more is the oxidation state, more is the acidic character. Please do remember that. That also was discussed in the basic concept of inorganic chemistry, where 1 to 4 videos were for this purpose only. Similarly, if you are comparing the same oxidation states like N2O4 and P4O8, their oxidation state may be same. And you should be aware of that. Non-metal oxides are acidic in nature and metallic oxides are basic in nature. So if you compare the +5 oxidation state, the molecules N2O5, P4O10 should be there, I feel so. Okay. And AS2O5, SP2O5, Bi2O5. So here all the oxidation state is +5. So here in this case, non-metal is nitrogen, and as you go down the group, in group 15 element, down the group, basic character increases or metallic character increases. Metal oxides are basic, bismuth is metal, so metal oxides are basic, fine. Acidic character decreases down the group for oxides. So this fundamentals very strongly you should keep in your mind and apply. If you are not clear still, I will just suggest you to go through the videos which we made for basic understanding of inorganic chemistry. So these are the structures. Structures you have to do practice, nothing else. Some basic logics, how many bond nitrogen can form maximum, these things only you should have. So this is when dotted is shown, it's showing the resonance, means either the bond would be, because either there will be a bond between nitrogen and oxygen of this sort and not this sort. So that's why it's shown, somewhere might not be shown also. Let us see this way, they have not shown that, but we should draw that bond. This way it's not correct. Okay. Now, so here these are the oxides. Nitrogen already we have discussed. These are the gases. N2O is colorless gas, NO is also colorless gas, and N2O3 is blue solid, NO2 is brown gas solid. When it will be, we are decreasing the temperature. Okay. N2O4, N2O2 is brown gas. This is very important. And you should know about the structure also. NO2 is this structure, not the single bond. This is partial double bond is there. Fine, here also. Let's see. And so these are all these things are there. We should keep in mind. Very important, all these things. N2O5 can exist in this form also. So colorless ionic solid, NO3 unstable radical. Okay. Now, these are some of the different oxides of nitrogen, and different uses has been given. Nitrite is oxidizing agent, nitrogen dioxide. H is converting to nitric acid, dimerization, and N2O4. Nitrate ion is basic solution and nitric acid is an acidic solution. Oxidizing agent to produce NO gas or reducing agent. It can act as both oxidizing agent or reducing agent. So here how we can decide that? This way. Because if you find the oxidation number, it's 3. 3 can change into 5 and 3 can change into -3 also. So if the oxidation number can increase and oxidation number can decrease, if oxidation number is increasing, it means oxidation is taking place, it means acting as a reducing agent. And if the oxidation number is decreasing, it means reduction is taking place and it's acting as oxidizing agent. It means nitrite ion can act as oxidizing agent as well as a reducing agent. So this fundamental concept you should be very clear when you are taking off in organic chemistry. Okay. And nitrogen oxide is also called nitric oxide, a colorless gas produced by the reaction of atom with dilute nitric acid. Please, we will do in the next video, we will do the reaction between the copper and nitric acid concentrated dilute. So these are fundamentals will be used here. Whenever copper is treated with concentrated nitric acid, NO2 gas will be released. When we are treating with dilute nitric acid, see here, dilute is written here, dilute, then NO gas will be there. Okay, NO is colorless gas, and which can be changed to reddish brown gas on reaction with oxygen. So similarly, nitrogen is laughing gas, and nitrogen is in the air and unreactive hydroxylamine, and this is hydrogen. disproportionate. The nitrogen is same, it undergo oxidation as well as reduction. The similar same element is getting oxidized and reduced. Ammonia. So these are the, you can read once more. So these are the different nitrogen oxide ions and various uses. So now anomalous behavior. Anomalous behavior is what? Nitrogen is a gas while other elements are solid, like phosphorus. Nitrogen is a diatomic N2, but phosphorus is tetra P4. Nitrogen and ammonia can form intermolecular bonding, but other members cannot. Multiple bonding. Nitrogen have a triple bond. Phosphorus P4 is having single bond. Nitrogen shows a wide range of oxidation states from -3 to +5. Okay, so but in this case, hydrogen, if you take calcium magnesium nitride, that's -3. If you take NH3, that is +3, or NCl3 +3. Multiple bonding is more prevalent in nitrogen as compared to other members. Multiple bonding in nitrogen triple bond. So now here same, ammonia is stable, but arsenic does not. Trilights of nitrogen are unstable. NCl3, NBr3, Ni3, no, that's not stable. Nitrogen does not form pentalite whereas other members do. Nitrogen does not form complex because they are not having d orbitals. So d orbital not there, the tendency for complex formation very less. And this is pentalite because of absence of d orbital, unstable because of poor overlapping, and ammonia is stable, arsenic because of bond stability or thermal stability. And this is wide range of oxidation states from -3 to +5. That examples we can explain all these things. And multiple bonding, triple bond is there because of small size. It can form, and the bond length is large as compared to here. Bond length would be very weak in case of phosphorus. We do more in the coming chapter of phosphorus topic. And nitrogen, ammonia, intermolecular hydrogen, I think so that we have discussed already. Okay, so why it is so? Why answer here? It is because of its small size and because of its high ionization energy and high electronegativity of nitrogen, and because nitrogen does not have any vacant d orbital. Okay, so now this is the summary. If you see, we have discussed about some of the name of the element: nitrogen, phosphorus, arsenic, cadmium, bismuth. We know that ionization energy is decreasing down the group. Common oxidation state is -3 to 5, 5, 3, -3, 5, 3. So these are the oxidation states. Ionic radius down the group increases, and electron affinity, you know that it is decreasing. And if you talk of electron activity, it is also decreasing. And reduction values, E naught value is becoming here positive here, and here this is negative. Okay, these are experimental values. Product of reaction with oxygen is forming NO or NO2, phosphorus pentoxide, arsenic oxides, and stellium oxide, and bismuthine oxide. And here type of oxides are acidic, neutral, and acidic, amphoteric, and basic. You know the metal oxides are basic in nature. And production of reaction with nitrogen, they are such that same, not combining any, forming any products. In case of halogen, it is PCl3, PCl5. These are less commonly we are finding. And here bismuth and BiF5, BiCl3. Okay, so now here also question can be asked is BiF5 and BiF3, which is more stable? Then you will say BiF3 is more stable. Why? Due to inert pure fat. Okay. So hydrogen, same, that the product of reaction is hydrogen. So nitrogen, hydrogen, ammonia, and all that can be there. Okay, let us see. We can understand that what we have done so far. This is the maximum reducing in hydrides of group 15 element. Which is the maximum? Which is the hydride having maximum reducing property? Can you answer that? Answer is bismuthine. Now the group thermal stability decreases, the reducing property increases. So let us take up the next question also. Having the maximum acidic character. Acidic character, if you see, these are the options with you. And here you have to calculate the oxidation number. If you find that, if you have calculated the oxidation number, you will find that which is the maximum oxidation number is N2O5. Therefore, acidic character is maximum for N2O5. Okay. Next is one more question. Hybridization of PCl5. So if you have calculated well and good, very nice. Otherwise, we can explain how we have to solve the hybridization. The central metal atom, phosphorus, this is a type, different types are there. Accordingly, we can find the hybridization. And this is the formula for that of the number of valence electron. Number of valence electron is 5. Number of monovalent is 5. 5 plus 5, 10. There is no anion, no cation, so 0, 0. And by 5 we are getting Z is equal to 5. Z is 5 means sp3 hybridization. More information you want how to calculate hybridization? I think we have calculated nearly 10 or 15 examples explained properly in the video of basics of inorganic chemistry, video number 4, hybridization. You can refer that. Okay, let us move to the next question. Which of the following is more covalent? More covalent is, you have to write these examples. Now here in this case, chlorine atoms are same. Number of chlorine atoms are same. What is changing? The central atom is changing. So central atom, nitrogen, phosphorus, arsenic, if it is there. So you know which rule? Which rule? Poisson rule. So Poisson rule says, smaller the cation, larger the anion, greater the covalent character. So which will be more covalent is NCl5. Okay. So if you want to know more about Poisson, so you can just check the inorganic chemistry basic videos 1 to 4. If you are able to solve it in a good manner, that's good. And further, these are the questions which has been given in your assignment also. So I feel that you will be able to do that. Okay. So these are certain questions you should practice for more understanding. Okay. These are questions, 20 questions are there, already assignment is given to you. These are certain 2 questions for that. Okay, so let us repeat the thought. Dreams and dedication are a powerful combination. Okay, so thank you again. Bye.